Okay.
Oh yeah, that one. Yeah.
So test tomorrow on chapter 7, which is solving systems of equations. There's 3 ways to solve: graphing, substitution, elimination. The first 2 here decide whether the ordered pair is a solution. These are yes or no. Okay? You're not solving it. They're saying they solved it and they got x to be 2 and y to be 4, and they're wondering, is that correct? So in order to check, you just got to plug 2 in for the x and 4 in for the y and see if it is. 4 times 2 is 8, plus 4 is 12. No. So that's no. So here, if we plug 1 and 1 in, 2 times 1 is 2, plus 1 is 3. That one works, but you got to check them both. 1 minus 2 times 1 does equal negative 1. So that's yes. So they got to work in both of them in order to be a solution. Okay, graphing. In order to graph these, you got to put them in slope-intercept form. So you just move this over and it'd be y equals, this would change from negative to positive 3x plus 6. So when you graph it, it crosses at 6. Can you see the lines on yours? I'll just draw one. So it crosses at 6, and it's got a slope of 3. So you put it over 1. If you rise 3 and run 1, you'll go off the graph, which is fine. It's not wrong if you do that. But if you want to stay on it, just write it as negative 3 over negative 1. That's the same thing as 3 over 1. So you could go down 3 and left 1. And if I just keep it going down 3 over 1, it would cross right there. Okay, so the other one, you got to move the negative x over. So it'd be y equals, this would change to positive x minus 2. So that crosses at negative 2. And the slope, since there's no number in front, it means it's a 1 over 1. So you rise 1 and run 1. Oh, this is an oddball one, isn't it?
You should go down. Mine made it to the bottom.
It did, if I keep going down? Okay, if I go, instead of up 1 over 1, go down 1 over 1.
It takes long.
Down 1 over 1.
I went by 2s.
Down 1 over 1. Let's see, and this goes down 3, 1, down. It looks like it's going to cross right there. Which is left 1, 2, 3, 4, and down 6. Now you can check that to make sure it's right, just like we checked up here. Plug in negative 4 and 6. Negative 3 times negative 4 is 12. Plus 6 does not equal 6. Oh, it's negative 6. Sorry. Left 4, down 6. So that one does work. And then if I put negative 4 and negative 6 in there, remember a negative and a negative makes positive 4. Plus a negative 6 does equal negative 2. So that is the solution. Okay, yes. So the next one are the easiest ones to graph. X equals 6 crosses the x-axis at 6. that is the straight up, that goes through 6. And then y equals -3 crosses the y-axis at -3. So then, yes, remember to put the solution. It's 6 over 3 down, where they intersect. Okay, then use substitution. Yes, you gotta use substitution. I can tell if you do or not. If you don't, you get points taken off. So this one is set up, this one isn't the greatest one for it. But here, the y is by itself. So you just take what it's equal to, replace it in the other equation. So instead of the y, I put what y is equal to, x plus 2 in place of it. And, you know, you normally would have to have parentheses, but since it's a plus in front, that doesn't matter. If this was a minus sign here, you'd have to put parentheses, which means change this sign and change that sign. So when you solve it, since it's a plus, you can disregard it. 2x and x makes 3x. Plus 2 equals 8. So you subtract 2, divide by 3, and x is 2. Then, since you know that x is 2, you can plug it in either here or here. This one works best for that x. Y equals 2 plus 2, which is 4. Now the next one isn't set up for a substitution. If you had a choice, you would use elimination on this. So what we got to do is get, the easiest thing to do is get this y by itself. So move that over, and it would be y equals, this would change to 2x minus 2. Then we can substitute that in for that y right there. So, in place of the y up here, again, we got the 2 times all of it, so you put parentheses. We put in 2x minus 2. So then we got to simplify this before we can solve it. So it's 6x. 2 times 2x is positive 4x. 2 times negative 2 is negative 4. You can combine those two, they're x's. 6x plus 4x is 10x. And now you solve it. Add 4. So 10x equals 20, so you divide by 10 and you get x equals 2. Then you can substitute that in any one of these. This is the easiest to put it in right there. Y equals 2 times x, which is 2. So 2 times 2 is 4. Take away 2 is 2. Okay, so on the next page, you can use any method you want. So this first one is set up for a substitution since the y is by itself. So the quickest thing to do would be to plug that in place of the y. Here's a case where there is a minus there. It's 2x take away whatever equals 0. So in place of the y, I put x minus 1. So since it's a minus there, when you rewrite it, the minus means you got to distribute it through. That would change that to a negative x, and it would change that to a positive 1. So 2x minus x is just x. So we subtract 1, and x is negative 1. So then to figure out what y is, plug negative x or negative 1 in right there. Y equals negative 1, take away 1 is negative 2. Okay, the next one, elimination. In fact, I think the rest of them, well, not that one. Not really that one. Okay, so elimination would work best. Everything is lined up. The x's, y's, equal signs. And the 2's have the same number, so they will cancel. Since the signs are different, you'd add. 2 plus negative 2 cancels. So that's what you do to the others. X plus 2x is 3x. These cancel. That makes 9. So divide by 3 and x is 3. Then in order to figure out what y is, you got to put 3 in, either there or there. It doesn't matter. If I put it in the first one, just replace the x with a 3. Rewrite it, and then you just solve the equation for y. Get the y by itself. Subtract 3. Divide by 2, and y is 1. This one, everything is lined up, but they're not matching, right? Nothing matches up, the x's or the y's. So if I wanted to match the x's up, I'd take it times 3. So this first one's going to stay the same. Here I take this times 3, you get negative 6x. Take that times 3, you get positive 18y. And take that times 3, you get 27. Everyone see what's going to happen? In order to cancel, you'd add 6x plus minus 6 is 0. And when you add that, you also get 0. And when you add that, you get 0. That's many, yep, because it's true. If you ever end up with 0 equals 0, it's many. Anytime the x or y both cancel, it's either many solutions or no solutions. So now this one, if you were to do elimination, you'd have to move this over. But this one actually is quick to do it substitution. I don't have the x by itself yet, but you could very easily by dividing by 5. So it'd be x equals 5 over 5 is 1, negative 10 over 5 is negative 2y. So then put that in place of the x, because x is equal to it. So in place of x, put 1 minus 2y, and then solve it. 4 times 1 is 4, 4 times negative 2 is negative 8y. Then I can combine these two, they're on the same side. So it's 4, negative 8y's plus 5y's is negative 3y's. So to get the y by itself, I got to subtract 4. And then divide by negative 3. So y is 2. So then to figure out x, just plug 2 in. This is the quickest. You can do these if you want. But if I put 2 in there, x would equal 1, take away 2 times 2 is 4. 1 minus 4 is negative 3. There shouldn't be any decimals on the test. So if you get a decimal, you just add it or subtract it wrong. Okay, now this one, it doesn't divide evenly like this one did, because if you divide this by 3, you get 1/3. So this one, it is easier if you just move the x over. So the top one we keep the same. Move the x over, we want to line it up with that, so it changes to negative x. This we didn't move, so it just stays positive 3y equals 15. Now the y's will cancel if you subtract. 7x's take away a negative x
8x.
is 8x, yep. Change the sign, change the sign. Negative 9 take away 15 is negative 24. So divide by 8 and you get negative 3. So then you can plug it into any equation. If I put it right here, rewrite it, it'd be 3y equals x, which we figured out is negative 3. Negative 3 plus 15 is 12. Oops. So it'd be 3y equals 12. Divide by 3, and it is 4. Okay, this one too, the bottom, they have the y before the x, which is fine. The quickest thing to do would just be to move this over. So this one is going to stay the way it is. 3y minus 8x equals negative 14. You could flip those if you wanted to. Put the x first and the y, but it doesn't matter as long as you write the other one the same way. So when I move this over, it changes to negative 5y, so I'll line it up there, plus 4x equals negative 14. So I could match these up if I take, probably the quickest is just take the bottom times 2, because that would make 8x is right there. So again, the top's going to stay the same. The bottom would be negative 10y plus 8x equals negative 28. So, add to get these to cancel. Add, and that's negative 7y. Add, and that's negative 42. So divide by negative 7, and y is 6. So then you can plug 6 in any one of these. This is maybe the quickest. So if you rewrite it, it's 4x equals 5 times 6 is 30. Minus 14. 30 minus 14 is 16. So divide by 4 and you do get 4. So there wasn't an example here, but remember there could be a no solution on there. The no solution would be like 0 equals whatever, something that's not true. You guys remember that? So if you get that, then it's no solution. Okay, then we get to what we just did last. We got to graph both of these. So these are set up into y equals mx plus b. It crosses at 3. It's got a slope of 2. So remember, make it a fraction. Rise 2, run 1. Don't forget it's either solid or dotted. This one is solid because it has the equal. The second one is dotted because it doesn't. So and then you got to shade one side or the other. Y is less than, which means everything below is gonna be shaded. So you could either lightly shade it or just remember it's everything below. This one crosses at 5. It's got a slope of negative x, which is negative 1 over 1. So you go down 1 over 1. You can keep doing that if you want to get them straight. This doesn't have the equal, so it's dotted. And this says y is greater than, so it's everything above. So can you tell which part would be double shaded? Right there. Because it's below this line and above that line, which means it'd be right there. Okay, these two are not in slope-intercept form. So you gotta move the x over. It would be y is less than, it would change to positive x plus 2. This would change to y is greater than or equal to positive x minus 2. So the slopes are the same, so they're gonna be parallel. So when we graph it, this one crosses at positive 2 with a slope of 1. So it's up 1 over 1. This one is dotted. And y is less than, so that's shaded below. The other one crosses at negative 2. It's got the same slope, 1 over 1. It has an equal, so that one is solid. And y is greater than, so that's everything above it, which means in between is shaded. Gonna be all right, Parker? Okay, so here we just have two of them. This one's solid, this one's dotted. Y greater than or equal to 2 crosses the y-axis at 2. It is solid because it has the equal. Greater than would be everything above it. X less than negative 3 crosses the x-axis at negative 3. This one is dotted because it doesn't have the equal sign. And x is less than, so that's everything to the left. So it's above this, left of that, which means it's this part that's shaded.